Okay, so we're launching this thing at 34 meters per second. It's at 56 degrees, which is some angle like that, right? Yeah, I put this in your notes. Okay. And does somebody have an answer?
We don't know.
Yeah, Durant's got an answer. How far is it going to go?
125.4.
What is it? 125.4? All right, so are we ready for this? Because see, this is a computer, and the computer is going to animate this. Are we ready for this? Okay, here we go. I don't know if you guys are ready for this, but and it looks like maybe we're off a little bit. Did anybody get something like around 110?
Yeah, I was sick.
108.3? Yeah, that's what we got last class. So maybe we'll figure out the 125 or something, right? Okay. So 108.3. They tell us that we missed. We weren't aiming for the target anyway, but I don't think it went 125.4. But it did actually go something like 108.3. Okay, so let's just fill in the numbers here and work through this, and then we'll make a formula, right? So I'm going to show you how to do it with the numbers, and then we're going to make it like a formula, a general formula that always works, right? So 34 sine of 56 is 28.187, right? And then the final velocity is negative 28.187. Yeah, isn't it? Yeah.
I got
109.3, yeah, that's close enough. I bet you just rounded differently. You're fine. Yeah. But probably if we carry like 5 digits, right? If we carry like 4 or 5 digits, we should be good, right? 5 ought to be a slam dunk, right? We won't be off by too much. Okay, now. No, probably not. Okay, let's be quiet. Okay, so now what we want to do is use this formula to figure out the time, right? So that calculation looks like this. Final is minus, it's VF is VI plus AT. So minus 28.187. That was a nuclear gum snap. All right, so calculate that. Every man, woman, and child, take your calculator, unless you're Shelby, who got the right answer, okay, and figure out what T has got to be. Yeah? I figure if you go through the calculations the right way. Ryan's going to do this too. Everybody's doing this. It's your neighbors are all doing it.
Do we have X, but do we have the X's yet?
No, we're just finding T. Yes. Are you maybe in radians or something? Sine, it gives you the Y. No, we'll.
5.75.
Yeah, there we go. 5.7525.
That's right.
Yes. Yeah, it's because like you and math are like loosely connected, right? Right. So you want to, when you do this, remember this becomes something like 56 point something, right? Yeah, not 0. Yeah, you did, didn't you?
No, I didn't do that.
You did something else, okay. All right. Class. Shh. Come back. Come back. Come back. Shut up. Could I have your attention? Please. Okay, so did everybody get something like 5.7525 for that, right? And then that comes across 5.7525. And then how do we figure out this? Well, we got to know what these velocities are, so you got to go 34 cos 56. So try that. 34 cos 56. Yeah, 19.01, I'll say 3 maybe, just for kicks. Are we good so far? Yeah, final and initial. Okay, so that's our horizontal velocity. It's always the cosine that gets us that. They're both the same. They're both, don't talk. They're both 19.013, right? And then how do we figure out x? Is it just this times this? It's this formula, VIT plus 1/2 AT squared. But there's no 1/2 AT squared. So it's just this times this. So multiply those together. You get 109.36. So I'm going to say 109.4. Does it say 3? And we got 109.4. Well, you know, I know. We'll see. We'll see. Are we good so far? A story, yeah. I'll tell you a story about deriving an equation. Okay, so we're good so far. Did everybody get this? Now let me just show you some tricks here. When you do enough of these, and you've probably done enough, right? I don't know if you figured this out, but when you solve this, isn't the time in the air really just twice the vertical velocity over 9.8? That's what I do. I don't actually put it in this formula and do it anymore. So it's just twice the vertical velocity. Don't talk. You guys are driving me nuts. It's just twice the vertical velocity divided by 9.8, right? Okay. Then this is really simple. This is always just this times this is this, right? Or this is this divided by this, right? This thing is always, guys, stop. Put that away. Close it. Thanks. Okay. So it's always this formula on this side. It's always dead simple, right? So now what we're going to do is we're going to derive a formula. This is going to be a general formula that works in all of these cases so that we don't have to do all this to solve that. Because we're in way too much of a hurry to win at like tank or something like that, right? Okay, so now let's start this same thing, only instead of 34, we're going to make that V, and instead of 56, we're going to make that theta. Now we're in formula land, yes? Okay, so this component here is V cos theta. This component here is V sine theta. Yeah? That's the opposite side, right? And then our range, this thing is going to fly through the air like this, right? It's going to land some distance here, and this distance here is called our range, right? And our range is equal to, well, the horizontal velocity times the time in the air. Isn't that always true? How far you go is always your horizontal velocity times your time in the air, I think, reliably. Okay? So all I'm going to do is substitute this for that, right? And then for the time in the air, I'm going to say that it's 2 times this vertical velocity over 9.8. Only I'm going to use g. That's what time is, right? So I'm going to substitute that for that. Yeah? And we're going to have a really good formula. 9.8. Okay, so I'm going to go V cos theta. That's my horizontal velocity. And then the time is twice the vertical velocity. So twice V sine theta over g. Now we have a formula. Isn't that beautiful? Yeah. Gentlemen. That is just a beautiful formula. So let's just try our new formula out just for kicks. I'm substituting. Yeah? So let's try this formula out. Let's see what the real answer is, right? G is always 9.8 on Earth, yes. Okay. So but before we do this, let's simplify this a little bit. I think we could write it this way. Can't I write it like that? I think I can.